So question 12, this is going to be a combined variation problem. So this is going to combine direct variation and inverse variation together. So solve the problem of combined variation using a constant variation. So again, when I say constant variation, they're talking about a value of k. So if x varies directly as y and z, and inversely with the square of r, so square kind of means a power of 2. And x equals 12 and y equals 4 and z equals 8 and r equals 4. So we have some information there. Then it says find x when y equals z equals 60 and r equals 12. So it looks like to start with, we're going to use this formula to start with to find what k is. So notice here though, they say x varies directly. So x is going to vary directly with y and z. So that's going to be k times yz on the top. And inversely with the square of r. So inversely means put that on the bottom. So we have this r squared on the bottom like that. So x is going to vary directly with y and z. So it's going to be multiplied together. Inversely with the square of r, that's on the bottom. And then we have to have our constant variation in the problem. So they do give us, we don't need an equal sign there. So we can just substitute in. So 12 goes in for x. We don't know what k is. The y was 4. The z was 8. And the r was also 4, but it's going to be squared. So I'm going to flip this around a little bit and do some math here. So k, and I have 4 times 8. And notice that 4 squared means 4 times 4. So I'm going to just leave that as 4 times 4, and then you have this 12 over here. So for me, it's easier to just kind of cancel out the 4s, and 8 divided by 4 would be 2. So this is just 2k is equal to 12. So I don't really have to use a calculator for that. And then if I divide both sides by 2, that will give me my constant variation. So k would equal 2. So now they want us to find x. So they want us to do this again, find x. But this time we know the constant variation is 2. And we know that y is going to be this 6, and this z is going to be 60. And on the bottom, we have 12 squared. So it's going to be, again, 12 times 12, if you will. So what I'm picking up on is 2 times 6 is 12. So we have 12 times 60 on the top, and we have 12 times 12 on the bottom. So instead of multiplying this all together, I can see that the 12s divide out. And 60 divided by 12 is 5, because I know that 5 times 12 is 60. So x actually just would be 5. And I really don't need a calculator to do that math. So 5 would be the value of x there. So that's some interesting math that they're kind of proposing there. So hopefully you find that useful in some of the manipulations you can do. So think about it before you start multiplying stuff together. You may be able to simplify quicker by just breaking things down and then putting it back together.